Hey everybody, it's Lee here. And if you wouldn't believe, it's a Friday once again. We're going to be finishing up the, well, I don't know, finishing, but we're going to continue working on the rear suspension of my 32 Ford sedan. Okay, so if this is your first time joining us, this is part 6 of my 32 Ford sedan build. I got videos on this car going right back to the day that I bought it and actually drove it home. Believe it or not, this was a running and driving car not too long ago. In the last video, we finished up the frame repairs and got the rear suspension kind of mocked up and sitting in here. This video, we're going to continue on with the rear suspension. We got to build some sort of mount for the front of the wishbones up here, and we need to build new axle plates to get the rear end sitting a little further back. This is pretty much the rear suspension setup that was in it. All we've done is replace the 32 Ford spring with a 39 Ford front spring to kind of move everything, move the wishbones back where they're supposed to be. But the axle is not sitting correct on the wishbones. It's too far forward, so our back axle is still a little bit too far ahead. We got to slide that back a bit. So that's what we're going to do on this video. We're going to start with this front mount here. Let me grab the camera. I'll bring you in and show you what my plan is. So these wishbones sit really nice right behind the K-member here. What I'm thinking I'm going to do is build a plate, probably a 1/4 inch, that follows this contour and will utilize these factory bolt holes. The reason I want to use the bolt holes is just because this is such a nice original K-member that I don't want to be the guy that cuts it up or modifies it. You know, someday somebody might restore this car back to stock. I highly doubt it, but if they do, or if they change something, you know, at least it's not welded on there. The other reason I want to bolt this piece on, basically I'm going to have a plate bolted on there with a little tab that will sit right there, and this bolt will go through it. So the reason I want to have the plate as well, just for a little more strength. I don't want all the pressure right on there. I could see eventually, maybe one day, that would start to crack or bend this K-member. So with it doubled up there, it should be plenty strong for what we're going to do. There's not going to be a lot of force going back and forth. It's mostly just going to be pivoting on here. So I think we'll start with that. We'll start making a template to fit in there. To make the template, I just held a piece of cardboard on there with a couple magnets, and then took a pen over to the back side and just traced our shape, and then marked the holes. So now we know what to make. So I've just traced my template, or not traced it, but measured it and drew it all up on Fusion 360 here. So now we can cut it out. The only thing I didn't do is I didn't put my holes, because when I was measuring them off my center line here, they weren't quite symmetrical. So I think when I traced them, they're not totally accurate enough that I don't want to make the holes. So what I did was, this is just like a little 1/8 inch notch, and that's the center line. So I think we'll cut this out the way it is, clamp it on the K-member, and then I can just come from behind inside the K-member and drill my holes straight through. It's not a big deal to drill 4 holes. So that's what we're going to cut out now. Ta-da! Okay, now we can take this, once it cools down a bit, we'll clamp it on there and drill some holes. then we can build our other piece. I got this thing all squared up in there and clamped in place, so now I'm just going to take a 5/16 drill bit and come through from the backside. And I'm not planning on drilling right through. I just want to make the mark, drill for a couple seconds just to get it so you can see where it starts, and then I'll take it off and drill it where it's not as awkward. 1, 2, 3, 4. And we can unclamp it. And there's 1, 2, 3, 4. So we'll drill those on the drill press. Bolt this guy in and then make our next piece. That bolted in there pretty nice. I'm happy with it. I grabbed one of these shock tabs. I got these on my website, and I originally built them as shock tabs. They're really thick though. They're 1/4-inch plate, which I realize is extremely heavy duty for a shock tab, but I make these out of like cutoffs from another piece that I make. So I grabbed one of these because they work so well on other applications like this. So I think I'm going to weld that kind of like there. And then we'll take a nice grade 8 bolt and kind of go through there. That takes a little bit of manipulation to get them to line up, but they do line up. So we'll bolt that in there, line it up, and weld it in. So I just want to point out a couple things before all the keyboard cowboys get in and start telling me what works and doesn't work. So I realize that in theory, in a perfect world, this should be on some sort of pivot point. The same as how the front wishbone bolts into like a little ball and cup deal up front here. That being said, I am pretty confident that just having a nice grade 8 bolt through there with this, I'm going to put a gusset on it as well. I think that's going to work just fine. One of the reasons why I say that is because when I took the car apart, that's basically how it was put together before, and you know, as janky as this car was, it actually like drove pretty nice. It was quite comfortable. And another thing is, you know, if it doesn't work, if I do start, you know, getting into doing some autocross or something with this, and it's going to have a lot of body roll and suspension articulation, you know, this isn't permanent. Just 4 bolts, it comes out, and we can completely build a whole new design. There's nothing when you're building a car, there's nothing that says what you're doing right now is a permanent thing. If it doesn't work out, just go back later and change it. Cars evolve all the time, especially race cars. Race cars evolve all the time. I don't know how many times like we've built something, take it to the track, oh, that didn't work. Bring it back home next weekend, blow it apart, rebuild it a different way, take it back. Works great. It's called trial and error. So that's point 1 that I want to make. Point 2, and some people have already mentioned this before, that these 36 wishbones, when you run them in an open drive situation like this, meaning no more torque tube, just a drive shaft, people say that they can bend. They're not strong enough. And you should run some sort of torque arm on there. And that makes sense in theory. Like the original torque tube does take a lot of when you accelerate and the rear axle wants to wrap up, the original torque tube takes a lot of that load. That being said, in the real world, I have yet to find and meet anybody that has actually had a set of 36 wishbones bend on them. I know you go on the ham, there's lots of people that say they do. Somebody's like old hot rod friend up the block had it happen. Somebody's uncle had it happen. But I have never actually met anyone who has actually seen it happen in person. That being, like I said, that doesn't mean it hasn't happened, but it's not that common. And I think in this situation, like this car has a stock flathead. It's got a stock top loader 3-speed. It's going to have bias ply tires on it. Like there's not going to be a lot of strain going through this. So I think it'll be just fine without a torque arm. And like I mentioned earlier, if I do find that it is a problem, then we'll fix it. We'll put a torque arm on it. But in the meantime, I'm not going to worry about it. I'm not going to stress out about it. We'll put it together like this, drive it, see how it is. If I decide later that I don't like it, then we'll just change it. Anyways, end of rant. Let's put this together. Man, that was a pretty good rant, wasn't it? I've been watching too many videos of one of my old friends, actually my dad's friend, Badge, when I was a kid. Oh, come on, it's so close, so close. Ah! Okay, now we just need to, this is not going to be the right size. Dang, I got to get a socket for that. Anyways, as I was saying, my dad had a good friend named Badge, who, he has a YouTube channel called Badge, Everybody Needs One, and he does a lot of like RV repair stuff. But he goes on rants like that all the time, so I'm sorry, Badge, I've been watching your channel too much. Okay, that is, if you're in the RV repair, go check his channel out. It's called Badge. Everybody needs one. And it's real, like, common sense how to fix stuff. Badge taught me a lot when I was a kid on fabrication and automotives and stuff like that. Okay, come on. There we go. That's the happy sound. I eventually got that bolt to go through, and I've got this sitting pretty square with our lineup marks on there. I think we'll tack it, pull it apart, weld it on the bench, maybe put a little gusset in there, and then put it back in. And hopefully, if that works out, we can move on to the back. Just cut out 2 little gussets here. So we'll weld one there and the other one in there, and then put this thing back together. This is very warm. Once it cools down, I'm going to bolt it back together. But I think it should be pretty solid. Here's the old one. This used to bolt to the bottom of the wishbone cup for the front. Because remember, it had the 32 spring, so everything was pushed further forward than it is now. So yeah, that just bolted to the bottom. And then the wishbones were bolted to there. And now they're bolted to there. So it's kind of the same concept, just a little more streamlined. Okay, let's jump on this and see what happens. Okay, we go up and down. And we go side to side. So, yeah, let's try it and see what happens. I think it'll be okay, though. Shane just dropped by to hang out for a bit. So we're going to put the front end underneath, just kind of temporarily. And that way we can measure the wheelbase to see exactly how far back we have to go. So I'll pick this up and you could probably just roll. Yeah. Okay. All right, I gotta find the wishbone cup. We'll bolt the wishbone up in place. So Shane and I just did some measuring on this thing and determined that the axle still has to come back another 1.5 inches. So we'll probably design some new plates that set the axle further back on the wishbone. We'll cut those out, mock them up, double check it, and then weld it in place if it's correct. Sounds easy enough. That should only take several hours. Now that I've got all the measurements that I need, I'm going to pick the frame up so that I can easily get access to the rear axle. Thanks to the assistant Shannon. Cool. Thank you. So in the last video when I put the spring in, I mentioned that these were a little bit wider than the 39 Ford wishbones that the spring came off of. So when we were going to take this apart, I was going to move them in a little bit. I just went and measured the 39 front wishbones to see where those have to be. And my tape measure must have been broken that day because it's only like, these are a 1/16 of an inch wider. So to bring it in, 1/8 of an inch on each side, I'm not even going to worry about it. I think I'm just going to leave this spring in here. Probably before I take the axle out, because it's under tension right now, I'll take just a piece of square tubing and I think I'll tack it across the front there just to hold everything. Then we should be able to unbolt this axle, take these mounts off, build new ones. We just got to move it back 1.5 inches is all, which looks like it should be centered in between these two bolts. Right now, the axle is almost touching the front bolts, and this back one, I can get like 2 fingers in there. So if we slide it back a bit so that it's centered in between there, I think it'll be okay. Another thing I'm toying with the idea of is when I build new ones, I might mount the axle a little bit higher. I don't know, kind of act like a lowering block, essentially. Lower it by lifting the axle a little higher on the wishbones. The chassis will sit a little bit lower. So I think we'll do that as well. But first things first, we got to get this out so I can make a template off of it. It's amazing how little weld was actually holding that on there. And it seemed to be working just fine. A little ugly, but it worked. So I've just drawn up a streamlined, much like the front bracket that we just did, a streamlined version of this. So originally I was going to make it kind of the same shape and stuff. However, this doesn't get welded to the wishbone, so it doesn't do really anything other than just occupy space. It's not adding any structural integrity at all because it's not attached to anything. It's literally just floating out here. Same with all this stuff back here. So I've narrowed that down. Now, originally, I was going to have this go all the way around, so the axle goes in it. I've done ladder bars like that. It's pretty common for ladder bar mounts and stuff. And I've always wondered, and I don't know the theory on this or the mechanical engineering side of it, but I've always wondered, when you take that complete circle, to get it on the actual rear end to weld it in place, you have to cut it in half. You slide one half on, you slide the other half on, and then you weld it back up. And I've always thought, like, once you cut that piece in half, doesn't that kind of like defy the point of having it totally round? And I mean, yeah, you weld it back together, but does it really need that top part? When you look at like a 4-link bracket, they usually only have half like that. You know, they're mounted this way rather than underneath. Or like a leaf spring saddle, they don't go all the way around. In fact, the leaf spring saddle basically only gets the bottom like 2/3. Now, keep in mind, a leaf spring saddle, you have 2 points where you weld. This you only have, well, no, because a leaf spring saddle, you would only weld one side and then the other side. You can't get the back side, whereas this, you can weld both sides. But that's a lot of weld in one concentrated point. Regardless, I think I'm really overthinking this because, like we mentioned earlier, this car's just going to have a stock flathead in it, and this is a Dana 44 rear end. So I think whether this is just a half saddle or goes all the way around, in this application, I'm going to probably break my transmission or break an axle well before this ever breaks. Especially, like I mentioned before, it's going to have bias ply tires, so it's not going to hook up. Not that it has power to go anywhere anyways. But I'd like to hear your guys' thoughts on this. I really like when I talk about stuff like this, stuff that, like, you know, theories, hearing people's comments and reading people's comments on it. Some people, there's a lot of people out there that are way smarter than I am, and I really like hearing what they have to say. There's a lot of people that really overthink stuff, and I always like hearing their opinion as well. And then there's some people that it's just so ridiculous. It's like, man, that idea would never work. But whether your idea is like a terrible idea or one of the genius ideas where I'm like, whoa, I never thought of that. That's brilliant. I want to hear about it. So tell me your thoughts on this. Should it go all the way around, or is just a half saddle suffice? Regardless, in this situation, we're going to do a half saddle. And if it breaks, I doubt it will, but if it breaks, then we'll make another one with a full saddle, and we can have a video on how to put that together. So let's cut this out. I'll cut one out, mock it up, and if that works out, then we'll try the other side. I mocked this guy up and it worked great, so I went ahead and cut another one out. Here, when I lay it over top here, you can see how much more streamlined it is. And also, when you flip it this way, you can see how much lower the car's going to sit. I made it so it should sit about an inch lower. We'll start there, and we can always play with ride height a little bit by adding or removing leaf springs or changing. If we put longer shackles in, drops it down a lot as well. So also with, when we were just talking about, you know, does this need to go all the way around and stuff, keep in mind this one was welded with this much weld. That was it. Just like one little corner. And it worked. It held. It didn't break. So I think this will be fine. These are both cut out and bolted in place now. They're nice and snug in there. I've flipped the axle upside down. We'll take a grinder and clean all this slag up, make this nice and smooth. Then we can kind of mock all this back up, square the rear end up, and we'll tack it in place. I've got everything all squared up in here. If we go from the axle flange to this outside edge, we're 8.5 inches on both sides. And then I also took this little T-square and just went from the shock bolt to the backing plate. And we've got 6 3/16. And if we go to this side, it is also 6 3/16. So we're square in there. I guess we should drop the frame back down and see what it looks like. Probably, if it's okay, we can tack it in place. I'm just going to tack it. I'm not going to go ahead and weld it up yet because I don't know what the pinion angle needs to be at yet. But if we just get it tacked, then it's pretty much ready to go. Once the engine's in, we can confirm the pinion angle and then weld it up. Everything looks good, so I'm going to give it some good tacks right on top here so that if we do have to readjust the pinion angle, it's easy to get to. Right now I've got it set at 3 degrees. I don't know if the engine's going to go in at 3 degrees or not, but if it does not go in at 3 degrees, it's no big deal to cut these 4 tacks and reposition it. Probably going to leave this bar tacked in until this is finalized. So yeah, I'll stack it. There we have it in there. I put the U-bolts back in and sucked it all down nice and tight. And I think it looks pretty good. I think one last thing that I would like to do probably before we finalize all this is I think I would like to set the body back on the frame. Just set it on there, line the bolt holes up, maybe put a couple bolts in. And I'd like to put the rear fender on just to triple check that it's in the correct spot. Because right now it's no big deal to move it further back or further forward if we have to. I've read quite a bit. Some people, they'll move the axle back 3/4 of an inch to line the fender up. Other people say it's fine. So I'd like to at least see what it looks like for myself and figure it out. But I'm sure this will be fine. Another thing I really want to do that I think I might have to do before I test fit the fender is I really want to get rid of these off-road truck tires. These are terrible. Stuart can have these for his Land Rover. Put them on his Defender because they're not hot rod tires at all. I've got a set of 820/15 white walls for the back and some 560/15 white walls for the front. So I think we'll put those on with, I've got a 55 Oldsmobile hubcap that I think would look really nice with that. Yesterday I was going to go get the wheels and tires changed, but I didn't realize that I kind of totally forgot. Yesterday was a holiday, so none of the tire shops were open. So, but I mean, it doesn't matter. We don't need those right away anyways. These tires, they hold air. They're actually almost new. So I don't know if anybody wants some really ugly tires. That basically wraps this video up. I think our next video is probably going to be, if it's not fitting the body, we're going to tackle putting this guy in. The engine and transmission, it's pretty much all ready to go. The other night I got the generator, or the power gen, and the fan and everything all mocked up. I'm curious to see how it's going to work. I was talking to my friend Bruce, and he said the APAs don't really fit that great in a 32 with the mechanical fan and the radiator in the stock location, or the firewall in a stock location. So there'll be bit of a challenge with that. We might have to get creative, but I'm pretty sure we can figure it out. I got it in a Model A, and they're considerably smaller. I got a stock fan on that one. Had to move the firewall back a little bit, but that's not a big deal. We can cut and weld stuff. Anyways, thanks for watching. Make sure to check out the website, lgspeedcustom.com. If anything from this video has inspired you, or you've decided that you want to build a hot rod now and want to say thanks, go check out the website, get yourself a hot rod shirt. LG Speed and Custom shirts, stickers, hot rod parts, all sorts of good stuff on there. Go check it out. And thanks to Christian Head for the music on this video. Check him out on YouTube, Headlines Pinstriping, Instagram, Headlines Pinstriping, and pretty sure he's on Facebook as well. Also, make sure to check us out on Instagram at LG Customs. So, thanks for watching. We'll see you on the next video.